concepts again. I'm not going to shred this yet or recycle it. I'll keep it here. So the natural log of the absolute value prime. Can anyone give us the answer? That's it. Thank you very much. Critical numbers come from
three sources?
two, just two. Good. And they are, can anyone help?
When f prime equals 0 and when f prime is undefined.
And I will put in parentheses, just to make it very clear, f of x exists. At that point, I mean. Okay, so these have to go together. So f prime is undefined, but at a point where the function exists. Good. Can a function have a max min where when it's continuous but not differentiable? Can a function have a max or a min where is continuous but it's not differentiable? Is it yes or is it no?
I think it's yes.
Absolutely. Absolutely. So here's why. Let's go back and make sure we understand this. Continuous. Not differentiable because it's a cusp or a corner. Not differentiable, but it has a minimum, a relative minimum. Awesome, thank you. So the answer is yes. Do all critical numbers turn into max min?
No.
No. Excellent. We have to do deep analysis on the sign change. If there is no sign change, left and right of the critical number, if there is no sign change, if it's negative, 0, negative, no max min. Negative, undefined, negative, no minimum, actually. Positive, 0, positive, no max. Positive, undefined, positive, no max. If there is no sign change, there is no max or min. If C is a critical number, how can C be a relative max or give a relative max or a relative min? For a relative max, positive, 0, negative, positive, undefined, negative. For a relative min,
-0. But, yeah. And negative undefined.
excellent. Negative, 0, positive, positive, 0, negative. Positive, 0, negative, maximum. Negative, 0, positive, minimum. Awesome. Thank you. I don't remember what I wanted to say with number 7, but I'll remember. So f prime gives. What do we learn from f prime about the function?
I think one of them is the max or minimum. And increasing and decreasing intervals.
Excellent. And the big deal, because without that big deal, we can never find these. What is the big deal?
Critical numbers.
That's it. So without critical numbers, we cannot find max min, and we cannot find, I mean, we can find the sign actually, but without critical numbers. But without critical numbers, we cannot find max min. Okay, perfect. I'd like to go back. I have the book ready. Where are you guys? I lost you. Okay. I didn't mean that. I meant this. Okay. So I want us to look at another, find the relative max, sketch the graph. No, we are not ready to sketch any graphs right now. So we're not going to sketch any graph. So we're going to just find critical numbers and find whether it's a max or a min, or it's increasing or decreasing on certain intervals. So let's choose another function. We only looked at a very simple situation last time. And then I would like to look at one of these problems here. You'll see in a minute why. Okay, so let's find critical numbers. Not sketching the graph yet. We're not there yet. I am going to choose 49. No one has the courage to choose yet. Okay, 49 on 277. And the function is g of x. Still a simple problem, simple function, polynomial, nothing sophisticated. It's not rational, it's not exponential, it's not log. I'll let you choose the next one in a minute. So it's not a sophisticated function, it's a simple function, polynomial. So we want to find critical numbers, and if the critical numbers give max min, how do we start? What is our first step here?
Find prime.
That's it. Find it f prime or g prime. Excellent. Good. Can anyone give us the derivative of this function? Calculate the derivative for us.
Would it be 3x minus 4?
So careful. 3.
X squared.
Yes. Minus
4x cubed.
4x cubed. Perfect. Good. So now we know in step 2 that critical numbers come from two sources, and we have to look at both. What is the first source? What is the second source?
Did we set it equal to 0?
Yes, or undefined. Since it's a polynomial, this is a waste of time. There is no such thing. This function is always defined. Awesome. So I have to solve this. So 3x squared minus 4x cubed equals 0. What is the degree of this polynomial?
Three.
Excellent. So I must find 3 solutions. Even if some of them are the same or all of them are the same, I have to find 3 solutions. Again, this is my preference, and I highly recommend it, however. This is a polynomial, as you said, degree 3, but it's not arranged in the correct order. Okay, I will do this. It has to be in descending order. Negative 4x cubed plus 3x squared. Now I don't like it because it has a negative leading coefficient. I'm multiplying everything by negative 1. So 4x cubed minus 3x squared equals 0. I will show you something on the calculator in a moment, but I want to finish this by hand first. What will you factor out, not divide, because we cannot divide by variables, but what will you factor out?
X squared.
Yes. And what is left in parentheses?
4x minus 3.
That's it. So now we have to find 3 solutions. And you will say, well, 2 of them are the same. What are they?
There.
Thank you. Great job. The other one is 4x minus 3. We move 3 to the other side. It becomes positive, so it's 3/4. So as expected, we found 3 solutions. Now, I want to show something with a calculator because I am allowing you to, and I encourage you to use it. So there is a feature, unfortunately not all calculators have it. So under apps, go down to number 9. So what I'm going to do, I'm going to start from scratch and allow me to record this, although it's recorded in the previous classes, but I'm going to record it again. So where's my recording? Yes, I'm recording on this computer. So we go to apps and then choose number 9, polynomial, blah, blah, blah. I'm not sure what this is. We'll see in a moment. Maybe it's explained. Polynomial root finder, number 1, click. The degree, they call it order. In our case, the degree is 3. Move over to 3. Enter. Enter again, or next, or graph. It may not be the same thing on the calculator, but on the software is this. So a polynomial degree 3 pops up, and it's asking us to fill in the coefficients. Be very careful how you fill them in. So the first coefficient is 4 for power 3, or degree 3. For power 2 is negative 3. But the other ones are gone. I meant negative 3. So the other ones, there is no degree 1 and there is no free term. So you're done. So these are 0. And then I think I have to click on graph, and here they are. So you automatically get all the solutions. So x1, the first solution is 0. The second solution is 3/4, which is 0.75. And the third solution is also 0. So stop recording. Okay. Stop sharing. So here it is. Now, we do have, or this function has 2 distinct critical numbers. Now, the second part of the question is, whatever you find as critical numbers, are they max min or none of the above? And the answer is, I have no clue. I will do my analysis, and then everything will be very clear. Let me see how I'm on time here. Oh, I'm still okay. Good. Page 3. X, f prime of x, f of x. Can anyone give us the domain? Oh, I'm sorry. G of x. Can anyone give us a domain of this function? Friendly or not? The domain.
All around numbers.
Of course, it's a polynomial function. Excellent. What we need to put in here, however, is 0 and 3/4. What do I write under 0 and under 3/4 in the row for G prime?
Zero.
Exactly 0. Now, this is the derivative. So, careful, right here. This is the derivative. Before This, when I solve an equation, I'm allowed to multiply by -1. But when I look at the derivative, I cannot change anything. I can change the order, but not the function. So I have negative x squared and 4x minus 3. Okay. In this function, we have to choose a number between negative infinity and 0, plug it in, and find the sign. In the same function, between 0 and 0.75, I will say 0.5, plug it in and find the sign. And then let's say plug in 10, plug it in and find the sign. So here I'm going to say negative 10, here in the middle between these two, 0.5, and to the right hand side 10. Yes, we can do this with a calculator, but it could be too easy. So let's see. I refuse to plug in x squared anything. Can anyone tell us why I am not going to waste my time with x squared? I refuse to plug in anything in x squared. Why? What type of number is x squared no matter what? When you take any number and you square it, real number, what type of number will this be forever?
Positive.
That's it. That's the reason why I will ignore x squared in my calculations. For the sign, only for the sign. So when I plug in negative 10, negative 40, negative 43 with minus in front, what is the sign that I should put in here? So with negative 10, negative 43 with minus in front, what sign do I put here?
Positive.
That's it. With 0.5, 4 times 0.5 is 2. 2 minus 3 is negative,
Uh-huh.
times negative in front. What sign should I
No.
put? Say it again.
Positive.
That's it.
Positive.
Excellent. Now with 10, 40 minus 3 is 37. With minus in front, what will be the sign here?
Negative.
That's it. At this point, I will plug in 0 in the function. Of course, I get 0. Here's the function. 0 cubed minus 0 to the 4th is 0. Now I have to plug in 3/4. So I have 3/4. G of 3/4 is 3/4 to the 3rd minus 3/4 to the 4th. Allow me not to waste your time and just doing it in a lazy way. So 0.75 to the 3rd and minus 0.75 to the 4th. That's the lazy way. Okay, so I got 0.1. Good. Now we want to look at the sign of the first derivative and decide what type of point is 0, comma 0. Is it a max? Is it a min? Is it none of the above?
None.
None, nothing, because there is no sign change. It's positive, 0, positive. So in other words, it's like this. Increases all the time. What about 3/4, comma 0.1? What type of point is 3/4, comma 0.1?
Max.
Yes, because it goes up and down. So this is a relative max. Awesome. That's it.